careless mistakes cause students to lose more points on tests than some misunderstanding of concept. There is a list of the most commonly made errors in algebra in your textbook, and I invite you to look at that complete list. I'm going to show you some of the high points here. Here's a situation where a minus sign precedes a parenthesis, and it's important to understand that we change the sign of every term within the parenthesis. The commonly made mistake is to just drop the parenthesis and write minus x minus 3. But this is incorrect. What we do is we think negative understood 1 times each term will change the sign of both terms, so we get minus x plus 3 when we expand the situation. Another mistake is in squaring binomials, where we think, gee, the fast way must be to just square the two individual parts, when in fact we have two factors of the binomial, and if we use the FOIL method, we end up with a trinomial as the result. So the mistake is this, and this is the correct result of squaring the binomial. When fractions are involved, some rather interesting situations can occur. You may already know that if you're dividing a monomial into like a binomial or a trinomial, that you can really think about the distributive property to deal with this properly. The 2 distributes itself as a divisor throughout this numerator. So really this is x over 2 plus 5 over 2. You see, we're kind of undoing the addition process. We often work problems from here to here. Add 2 fractions, they have common denominators, so we bring the 2 fractions together, you see, just by collecting numerators and attaching the common denominator. But we can kind of undo it also, just kind of work in the other direction. Now, it's not the case, though, that if we flip this fraction over, that this 2 becomes a numerator for both parts of the denominator. That just is fundamentally incorrect, and yet it's a mistake that's often made. Now, another mistake that's made with involving fractions has to do with cancellation. I find a lot of times that my students have the tendency to want to cancel the 2 here with the 2 that is a factor within 6. So, and the answer given would be x plus 3. Actually, you just leave this alone. It's not reducible or able to be simplified any farther. Here's an interesting situation where we want to take a fraction like this and kind of disband factors in a very special way. It's possible to write this as 2/5 times x. Now, notice that the x is in the numerator, and really we think of it like 2/5 times x over 1, which is 2/5 x. All right, so, and by doing that, we can see the distinct coefficient involved in this term. All right, but it's not the case that if the x appears in the denominator that this is the same as 2/5 x. It just isn't. This is 2/5 times 1 over x, you see, and typically we would leave the problem like this. Now, when you make fractions, if you make a slash for a fraction bar, then some troubles can arise. If we have something like 1/3x like this, it implies that the x is part of that denominator. And if you don't want the x to be a part of the denominator, then you have to separate the situation like this, that 1/3, you see, times x means 1/3 times x like this, or simply x over 3. When exponents are involved, it's important to know that when you raise powers to powers, you multiply the exponents like this, and you don't add them. And when you multiply like bases, you do add the exponents, and you do not multiply them. Now, the safe thing to do when you get into trouble with exponents, just write the situation or think of the situation as you understand the meaning of exponent. Exponents tell us the number of times the base is used as a factor. So if we just think that we have 3 factors of x squared, we have x squared, x squared, x squared. How many total factors of x do we have? We have 6 of them. You see, and here also, this means 2 factors of x, that means 3 factors of x. Altogether, we have 5 factors of x. So that's the correct form. Now, the notion of radicals and taking the square root of squares is what we're always looking to do. But when we have the sum of squares, this does not turn out to be x plus 5. That is, we can't distribute the operation of square rooting through a polynomial. That is, this is not the same thing as the square root of x squared plus the square root of 25. We can't just distribute it like that, and this is a commonly made mistake. Many students find that it is the algebra within calculus that is more challenging than the actual concepts within calculus. And it is because in calculus, often it's the case that we have to put expressions into a very particular form in order to go through some further manipulation. Let's take a look at some of those situations and some strategies for dealing with changing form of expressions. Here's a situation that we certainly have seen before. When we have a fraction like this, we can show a distinct coefficient here, a numerical coefficient, by separating like this, writing this as 5/8 times x to the fourth. All right, in a situation involving fractions, it's often the case that we want to, again, show like a distinct numerical coefficient of this numerator, and we can do that by thinking of it as 1/2 times x plus 5. Now notice that we're just forming a fraction of 1 over denominator times the numerator. You see, that's the idea. Now here, we're going to force a factorization to occur. Let's say that I want to force the factorization of, let's say, 2 out of this entire expression. Now you might say, well, gee, we don't have a 2 factor here, we don't have a 2 factor here. Well, we can force that factorization like this. We snag 2 out of this term in the usual way. We're left with x squared. Now, we can actually pull 2 out of these two terms by just imagining what we need to multiply against. You see, 2 is multiplied by something here to give these things. And so it's like we're pulling out a 2 factor, and what we need to put into these is something that would undo the idea of a 2 factor. And that would be a factor of 1/2, or dividing by 2 would negate the idea of multiplying times 2. Here's what I mean. I can rewrite this as minus x over 2. You see, and now 2 times minus x over 2 would leave the minus x. And in a similar way, I can just pop a 2 into the denominator of this term and write it as minus 3 over 2. And now when I multiply the 2 times the negative 3 over 2, I get the negative 3. So it's just a creative factoring technique. Here's another one, and this one is a little more involved because we have binomials involved in our expression. What we're trying to do is factor particular items out of these two terms. And the two items we're factoring are the, the binomial to the negative 1/2 power and this denominator. So we're going to take these two items and pull those items out of this term and force those items out of this term. All right, here's how it works. You pull this, now understand that this is an understood numerator. We can think of it as over 1. So we're pulling it out of this numerator, and we're pulling the 2 out of the denominator. So all that's left in this term is the x in that numerator. Okay, that's pretty easy. Now we want to pull this fraction out of that term. Now, first of all, think about pulling the 2 out. You see, so we're pulling a 2 out of a denominator here, and yet there's no 2 over here. But if we create a situation of something to multiply against, this idea we have this 1/2 times something over here that will offset one another, we'll just pop in a 2 factor here. So 1/2 times the 2, you see, would go out. All right. Now, the forcing of the factorization of the x plus 1 to the negative 1/2 out of the x plus 1 to the 1/2. Remember, at one point we may have talked about the notion that when you factor this out, you can think of subtracting this exponent from the exponent you have up there. So we would have then x plus 1 to the 1/2, which we already have, minus the exponent that we're taking out. You see, that's the idea. We can probably do this mentally a lot of times, but at first you want to write all of the little components to the situation. 1/2 minus negative 1/2 is 1/2 plus 1/2, which is simply 1. So here then is our factored form. Now I mentioned earlier that we can write a distinct numerical coefficient like this, 5/8 x to the fourth. But what if we have 5 over 8x to the fourth? You see, what about a distinct numerical coefficient involved here? Well, we can actually manipulate this x to the fourth factor that appears in the denominator now. We could kick it up into the numerator if we want to, using a negative exponent. You see, when it moves to the numerator, a negative exponent makes its appearance. And so it would be x to the negative 4. And then we can think of it exactly like that to write 5/8 x to the negative 4 power. Now we would probably just go directly here and not actually move it up into the numerator. We would just go to this step. But that's the idea. Now in a similar way, we can think of this denominator, this square root of 2x minus 3, as being 2x minus 3 to the 1/2 power. And then we can kick it to the numerator by using a negative exponent. You see, we can write this fraction as 7 times 2x minus 3 to the negative 1/2 power. Here's an interesting one. Now, this means the same thing as that. And I'm again going from this radical form to the fractional exponent form, and then from the fractional exponent form in the denominator, I'm getting this factor up into the numerator by using a negative exponent. So now if I would write an intermediary step, it might be one like this. I can think of this in a lot of ways. I can actually, oh gee, I'm going to get confused here. There's so many nice ways to do this. Let me look at it like this. This is x to the 1/2 in the denominator. And I can think of dividing x to the 1/2 into each of these components up here. Right? And it's pretty easy to see that way. This is x to the understood 1. So, and I'm dividing here, so I subtract the exponents. I have 1 minus 1/2, and that leaves x to the 1/2. And here it's the same idea. I'm dividing into this term, so it's x to the 2 minus 1/2, which is x to the 1 and 1/2, or x to the 3/2 for that particular factor. And then 1 over x to the 1/2 is x to the negative 1/2. Now, another way, that interesting way that I was going to show you a moment ago, is to kick this x to the 1/2 into the numerator as a factor by using a negative exponent. Think of it like this. You see? Then we can actually go through and multiply, whoops, that's plus 1, and multiply in the normal way, x to the negative 1/2 times x to the understood 1, add those exponents, and we get x to the 1/2 over here as expected. And then again, just multiply through as we normally would, and here's our result. So a couple of ways to deal with it. Here's a really clever situation involving fractions. We know that when we have an algebraic fraction and we have a polynomial numerator and a monomial denominator, that monomial denominator can be thought of as a divisor for every term of the numerator. Okay, we can use that kind of concept here and think of separating this fraction into two fractions by thinking of this as a single item. You see, it's a single binomial, and we can think of that binomial under the x and also under the 3 kind of as separate fractions. It's kind of undoing the idea of adding the two fractions. After all, we've gone in this direction many times. We have a common denominator, we simply add numerators, you see. Well, we're undoing that here, going the other way. Now, an even more creative way to extend that idea is this. Suppose I want to create a certain kind of form in which I have a binomial, in a certain binomial in a numerator. And that binomial is 2x plus 3. Well, I can take this 2x numerator, and in that numerator I can add 3 and subtract 3. Now the effect here is nothing, but now I can go through this separation process and think of this as one fraction and that as another fraction. So I can write 2x plus 3 over x squared minus 5, and then minus 3 over x squared minus 5. And you might think, well, why is that ever going to be important? Well, we would have to wait until we get to calculus to really see how important it is, but I can show you one situation where it might allow us to simplify or change the form of a particular fraction. Here it is. We have x squared minus 2 over x plus 1. Now we might be thinking, gee, if we almost have a situation up here where we have the difference of squares, but 2 is not a square. However, we can create a situation where we have the difference of squares like this. We can think of minus 2 as minus 1 minus 1. You see, like this. Separate it like this. And now separate fractions like this. You see, so x squared minus 1 over x plus 1, and then the minus 1 over x plus 1. And here we factor into x plus 1 times x minus 1. These factors go out, and we're left with x minus 1, and we just bring this fraction down. rather interesting kind of manipulation, wouldn't you say? Sometimes in calculus it's necessary to put in a certain factor, and you therefore have to kind of undo whatever it is that you did to put that factor in. For example, here we start out with something that looks rather simple, but suppose we need a 5 factor in here. Well, all we need to do to have a 5 factor is to also have a 1/5 factor. You see, so 2 factors can simply offset one another to meet a certain form. Now, here's another example of that same situation, but it looks pretty much more complicated. Notice first, though, that 4x cubed minus 5 to the 1/2 power appears here, and it also appears here. So that's not part of the of what we're doing in adding a couple of factors that offset one another. Now, do notice this, too, that we have x squared here, but this x squared factor has been moved to a position way over here. Notice that we have a 7 here in an understood numerator and a 7 here in an understood numerator. The only difference in these two forms, with the exception of just moving some factors around, are the two 12s that we see over here. We multiplied by 12 and also divided by 12 to offset that multiplication. So we're just putting this into a certain form involving a 12 factor, you see, and we have to undo that 12 factor here, and the x squared was kind of shifted over to another position. But it's important to be able to realize that these two are equivalent expressions. Now here's an interesting situation, and our goal here is to rewrite this expression so that we have only x squared in this numerator and only y squared in that numerator, understood numerator. And so we're going to clear this 4 and we're going to clear that 4. Now, and we want an equivalent expression. We don't want to change the value, only the form of this expression. And we can do that like this. We want to clear this 4, so we're going to need to multiply this by 1/4. But if we multiply by 1/4 up here, we need to be multiplying by 1/4 in this denominator. So that's the technique. So we're just multiplying by 1/4 in both numerator and denominator. We'll do the same thing here. Now I'll just show it out to the side. We are going like this, 1/4 over 1/4. So that's what we're doing. You see, now 1/4 times 4 would be 1, so in this overall numerator we have simply x squared. And in the denominator we have 1/4 times 9 is 9/4. You see, and then over here, same idea, the 1/4 times 4 is 1, so we have minus and then y squared for the numerator, and in the denominator we have 1/4 times understood 1, which is 1/4, so like that. Here's an interesting situation. We want to try to discover what belongs in this parenthesis. I want to evaluate what needs to go there, though. We need to see what we have here compared to what we have over there. We have this trinomial squared in this denominator. Well, that same trinomial is right here squared in this denominator. So there's no change in that part of the expressions. The x plus 2 appears in this numerator, but we have 2x plus 4 over here. Now, how are these two related? Well, let's see. There's a 2 factor in here. This is really just 2 times x plus 2. So there's an extra 2 factor in here compared to over there. Now, how do we undo the idea of tacking on an extra 2 factor? Well, we undo it by popping in a 1/2. 1/2 of the 2 would offset one another, but we have met a particular form for calculus in doing this. Here's one where we just want to rewrite, and let's use negative exponents to write this as a series of 3 terms. Now, by that I mean this. I want to use negative exponents to move the variable parts into what may appear to be a numerator, or take them out of this denominator setting. So here, as we saw earlier, this could be written as 2/5 x to the negative 3 power. You see, distinct coefficient, and moving that variable factor into our numerator. And here again, with radicals, we think of radicals in fractional exponent form. This is really x to the 1/2 power. And then when we move it up into the numerator, it's x to the negative 1/2 power. And then here, it's a similar idea. There are several things we can do with this one. We could square the 4 and the x and have 16x squared down here, and then 5 times the 16 would be 80 and so forth. Or we could maybe do something like this. There are just a lot of ways to do these things, but one way is like this. Just move this entire item up to as a sort of a numerator item by using the negative exponent notion. Another interesting manipulation.